Hurricanes. Hurricanes. Focus question. How do people use science to help prepare for hurricanes? A hurricane is coming. This just in from the National Hurricane Center in Miami. A hurricane watch is in effect for Florida's east coast from Florida City to Flagler Beach. Hurricane Frances is about 555 miles east-southeast of Palm Beach and is moving toward the west-northwest at about 14 miles per hour. The message crackles over a radio at a small Florida cafe. The patrons look outside at a warm, sunny day and then out to sea for any signs of the approaching storm. There are none. However, the television shows a satellite image of a gigantic spiraling storm. A dotted line shows the hurricane's path. A shaded wedge shows where the hurricane might hit the coast. The people in the cafe have already been hit with one hurricane this season. They know they must prepare. Some put more materials to board up windows. Others get supplies at the grocery store, such as water, food, and batteries. The next morning, the wind speed picks up, and the sky clouds over. Some people further down the coast evacuate or leave their homes to go to safer areas. Winds reach hurricane strength, bending over palm trees. The wind rips roofs off buildings and flying objects become deadly. High waves and rising water flood low-lying areas on the coast. Falling trees break power lines. Some people who were not evacuated sit in the darkness of their homes. They listen to the storm's progress on their battery-powered radios. Finally, the storm moves inland and the wind slows down. Heavy rainfall and flooding remain. The next day, the sun comes out and people begin the coastly cleanup. What is a hurricane? We have all experienced wind and rainstorms, but what makes a hurricane different? Hurricanes are gigantic, circular storms that can be hundreds of kilometers wide. When they happen in the Pacific Ocean, they are called typhoons. In the Indian Ocean, they are called severe tropical cyclones. In the Atlantic Ocean, they are called hurricanes. No matter what they are called, the result is the same. Heavy winds and rainfall along with high seas can cause death and billions of dollars in damage. Hurricanes have a distinct structure that can be seen on satellite photos. Clouds extend out as spiraling arms for hundreds of kilometers around the center. The center of a hurricane is called the eye. Winds become more and more intense from the edge of the storm to the eye wall. The eye wall is where winds rushing toward the center suddenly turn upward. This air cools very fast and rain begins to fall. Most of the rainfall happens in the eye wall. Sometimes rainfall reaches 20 millimeters, 0.78 inch, of rain per hour. This can dump about 15 to 30 centimeters, 6 to 12 inches, on one area over several days. Yet, inside the eye, it's often calm and sunny. Most hurricane eyes are 30 to 60 kilometers, 20 to 40 miles in diameter. In the eye of a hurricane, the peacefulness will not last long. Soon the eye will move. Then the sudden force of the other side of the storm will hit. As hurricanes approach shore, the combination of high winds and low air pressure raises the level of the sea around the storm higher than normal. Scientists call this a storm surge. It extends 4 miles around the center of a hurricane and floods any low coastal land. Flooding caused by a storm surge is a major source of property damage from hurricanes. How hurricanes form. Hurricanes form over tropical oceans worldwide. These tropical storms tend to be seasonal. They usually form in the summers of the northern and southern hemisphere. The storms form when energy from the sun hits ocean water near the equator, where moist air evaporating from the ocean is lighter than the cooled, dry air above it. The warmer air pushes up through the cooler air. The cooler air then sinks down to take the place of the warmer air. The process creates a low-pressure area called a tropical depression. Do you know? In the northern hemisphere, hurricane winds rotate counterclockwise. In the southern hemisphere, hurricane winds rotate clockwise. As the warm, moist air rises, it cools and condenses, a process that creates clouds and releases heat energy. Soon, giant thunderclouds form. Wind begins to rotate or spin around the low-pressure area. The wind starts blowing harder when it reaches about 62 kilometers per hour, 39 millimeters per hour. The tropical depression becomes a tropical storm. Tropical storms can grow into hurricanes if they soak up more heat energy from the warm oceans they pass over. Some storms don't ever gain enough energy to become hurricanes. If a tropical storm does gain more energy, wind speed picks up the thick spiral bands of clouds spread out from the center of the storm. When wind speeds are greater than 119 kilometers per hour, 74 meters per hour, the storm officially becomes a hurricane. Naming system. When a tropical storm officially becomes a hurricane, it is given a name. The yearly name lists for each region of the globe reflect all nationalities because hurricanes affect people in many countries. Here were the names for Atlantic Ocean hurricanes for 2010. Alex, Hermine, Otto, Bonnie, Iger, Paula, Colin, Julia, Richard, Daniel, Carl, Sherry, Earl, Lisa, Thomas, Fiona, Matthew, Virginie, Gaston, Nicole, Welter. Generally, hurricanes in the northern hemisphere move west, then north. Then they turn toward the northeast. This path takes hurricanes away from the equator and away from the warm ocean water that fuels them. In the southern hemisphere, hurricanes typically travel west-south and then turn southeast. This path also takes them away from warm ocean water. As hurricanes move over cooler water and over land, they lose much of their energy. The wind slows down and the storms eventually disperse. Where hurricanes form. Central America, islands in the Caribbean, and the east coast of the United States are hit by hurricanes almost every year. Rarely do hurricanes hit the U.S. West Coast. Atlantic Ocean hurricanes get started southeast of the Caribbean Sea. In the Pacific Ocean, typhoons most often hit Asia and Indonesia. In the Indian Ocean, severe tropical cyclones affect Australia, the Middle East, parts of Asia, and the eastern coast of Africa. Hurricane season can last 6 months or more. During this time, meteorologists watch tropical depressions and tropical storms hundreds of kilometers offshore to see if any will become hurricanes. How hurricanes are classified. A tropical storm has sustained winds of 62 to 119 kilometers per hour, 39 to 74 meters per hour. When a tropical storm has sustained winds greater than 119 kilometers per hour, 74 meters per hour, it is classified as a hurricane. Meteorologists classify hurricanes according to their intensity using the Saffir-Simpson hurricane scale. The scale goes from 1 to 5 and helps describe the kind of damage and dangers of each category of hurricane. Category 1 hurricanes have winds of 119 to 153 kilometers per hour, 74 to 95 meters per hour. They cause little damage to buildings and minor damage to vegetation. Category 2 hurricanes have winds of 154 to 177 kilometers per hour, 96 to 110 meters per hour. They tear away roofing material, damage doors and windows of buildings, and uproot plants. Boats in unprotected areas often break away from docks. Category 3 hurricanes have winds of 178 to 209 kilometers per hour, 111 to 130 meters per hour. They cause structural damage to small buildings and destroy mobile homes. Areas lower than 1.52 meters, 5 feet above sea level, may be flooded as far as 13 kilometers, 8 miles or more inland. Category 4 hurricanes have winds of 211 to 239 kilometers per hour, 131 to 155 meters per hour. They cause building walls to collapse and major erosion of beaches. Areas lower than 3 meters, 10 feet above sea level may be flooded, requiring massive evacuations as far as 9 kilometers, 6 miles inland. Category 5 hurricanes have winds of greater than 249 kilometers per hour, 155 meters per hour. The strongest hurricanes cause wide damage to houses, areas, and lowlands within 8 to 16 kilometers. 5 to 10 miles of the shoreline may be required. Historic storms. The most destructive hurricanes have been powerful and slow-moving. Many have destroyed major cities in their paths. Here are some famous hurricanes: typhoons and cyclones. Name: ocean areas most affected, year and death. Calcutta, Indian, 1864, 70,000. Galveston, Atlantic, United States, 19,000. 1,900, 6,000 to 8,000. Vera, Pacific, Japan, 1958, 5,000. Bangladesh, Indian, Bangladesh, India, 1970, 300,000 to 500,000. Thelma, Pacific, Philippines, 1991, 5,101 to 8,000 and more. Mitch, Caribbean in Central America, 1998, 11,000 to 18,000. Katrina, Central Gulf Coast, United States, 2005, 1,800 or more. How we study hurricanes. We use satellites to locate and track tropical depressions, tropical storms, and hurricanes while they are far out of the sea. Satellites orbiting high above Earth take frequent pictures of a hurricane. Scientists study the differences in the picture to measure changes in a storm's movement and intensity. High clouds within strong hurricanes show up on pictures from satellites as colder than the surrounding area. The most dramatic hurricane studied tool is the Hurricane Center. This is a specially damaged aircraft that flies into the eye of a hurricane. It makes direct measurements of temperature, moisture, wind speed, and direction. Doppler radar also helps track storms. Weather forecasters on television news programs use it to show local rainfall. Wide-range Doppler radar shows a hurricane's wind speed as it approaches land. Doppler radar stations send out short bursts of energy waves. Rain and clouds reflect these waves back to the station. Rain and clouds coming toward land from a hurricane reflect back different waves than rain and clouds headed away from land. A computer analyzes the differences in the waves to create a model of a storm. Scientists use the model to show the speed and direction of a storm. How we predict hurricanes. Computers are used to predict hurricanes' movements. Thousands of measurements are typed into supercomputers to predict where a storm will go. As computers improve, we will be able to better predict where hurricanes will hit land. This will save lives and reduce unnecessary evacuations. But computers will never be 100% accurate because weather systems are chaotic and are often difficult to predict. Some researchers believe it is possible to stop hurricanes from forming or to redirect them. One possible way to do this is by sending clouds in broad areas where hurricanes are born. During seeding, airplanes spray a fine mist of salt powder, which helps water condense out of the air. This would create many small clouds that would use up the energy that might be tapped by a single large storm to become a hurricane. The problem is that in order to be effective, clouds would have to be seeded over areas the size of Texas. No one yet has come up with a plan that would prevent a hurricane from forming. How to prepare for hurricanes. These steps can help protect the lives and property during a hurricane. Have a family evacuation plan, including the plan when you leave, where to go, how you will get there, and what to do if your family becomes separated. Keep emergency supplies such as a first aid kit, flashlights, drinking water, and canned food. Keep a battery-powered radio to listen to if the power goes out. Follow the instructions you receive over the radio with each elevated warning. Keep your car's gas tank full in case you need to evacuate. If you are in the path of a hurricane and you have time, protect your house by nailing plywood over windows. Tie down loose objects outside. Leave as soon as you are ordered to evacuate. Conclusions. Hurricanes are an awesome display of nature's power. Satellites can tell us much about these storms, such as the direction a hurricane is moving and what areas need to be evacuated. We may be able to predict the path of hurricanes, but it is unlikely that we will ever be able to stop them. We can protect ourselves by planning where and how we build our homes, by keeping emergency supplies, and by being prepared to evacuate if necessary. Explore more. On the internet, use www.google.com to find out more about topics presented in this book. Use terms from the text or try searching for glossary or index words.